Hey guys, this is Algebra 2 lesson number 4. We're going to do some of this lesson live, so this is not the beginning of the lesson. This is the last 4 pages of lesson 4. So we've already talked about multiplicities of functions. So let's take a look here. Graphing factored polynomials. All right, recall, roots or zeros of a polynomial function are the values of x for which y equals 0. These values will be seen on the graph as the x-intercepts. All right, so let's take a look. Find the roots of this function, x squared plus 2x minus 3. Let's do it algebraically. We can find the roots by setting the function equal to 0 and factoring. So we get x and x. Two numbers that multiply to -3 and add up to 2 are going to be +3 and -1. And this one's easy to solve, so we get x equals -3 and x equals +1. And then if I were to graph that, at -3 there's going to be a root 1, 2, 3, I'll put a dot there. And at +1 there's going to be a root, I'll put a dot there. And the parabola is going to have a look like this. The function is going to have a look like this. It's just a parabola. It goes through the x-intercept of -3 and +1. So when we set the function equal to 0, those are the roots. Those are the zeros, literally the zeros. That's why it's called 0, because it's where the value of the function is 0. Okay, higher degree polynomial functions. Now we're all used to seeing parabolas, but here we have a function that has a higher degree than a mere parabola. Parabola is quadratic with the highest term being squared. This is going to have a higher exponent than 2. So higher degree polynomial functions, a polynomial function of degree 2 has only one turning point. This is the turning point right there, and we'll have 2 zeros. A polynomial function of degree 3 may have more than one turning point, and we'll have 3 zeros. This one has multiple turning points, and it has multiple zeros. So the roots here are going to be, I got to count this over, -1, 2, 3, 4, 5, 6. So -6, there's a root. 1, 2, 3, 4, 5, 6. -2 is a root. +3 is a root. It's actually a double root because it's tangent to the x-axis, so I'll call this a double root. And positive, let's say 3, 4, 5, 6, 7, 8. +8, if I read that correctly, is also a root. So we got 1, 2, 3, 4. There's actually 5 roots, which means x to the 5th, has to be a function with x to the 5th as a highest power. Because you have 1, 2, 3, 4, and then since this is a double root, a 5th root. So basically, this is going to be a function with the highest exponent of 5. Okay, so you could always tell what the highest degree of a function is going to be based on the number of roots it has. All right, so let's go take a look at the next page. You probably know what increasing and decreasing is. Increasing is just that a part of the function where it's going up. So this function, I'm just going to point out to you. So it looks like this. I'm going to make it darker. So this is the function here. There's a few vertical lines here. You have the y-axis here, you have the x-axis here, and you have these two lines here. I'll explain what those are afterward. But the function is increasing here, the function is decreasing here, and the function is increasing here. These two vertical lines are where the turning points are. There's a turning point right here, and there's a turning point right here. Now, this turning point is called the maximum. This is the highest point in that region. Now, this function goes up forever, so it doesn't have a maximum on this side, it just goes up forever. But it does have a relative, we call it a relative maximum right here because it's like a mountain here. So there's a maximum here, and there's a minimum here. So when a function increases and then decreases, that part is a maximum. And this vertical line here is just to show you where it turned around, the turning point. There's another vertical line here. It's going from decreasing to increasing. So there's a minimum right here. And that, again, it's going from decreasing to increasing. And this is showing you the turning point. All right, so let's take a look at how we could sketch something like this. Let's sketch the graph x cubed plus x squared minus x minus 1. We could actually do it without using the calculator, and I'm going to show you how we're going to do this. So first of all, I'm going to write this a little bit larger. x cubed plus x squared minus x minus 1. I'm going to set it equal to 0. And I'm going to factor this by grouping like this right here. Here I'm going to pull out an x squared. And then we're going to get x plus 1. I'm going to bring down this minus sign here. Greatest GCF for these two terms is 1. And you're going to get x plus 1. And you might say how this went from negative 1 to positive 1, because we factored out the negative 1. And if we were to distribute, we'd get negative x minus 1. So now this becomes x squared minus 1 and x plus 1. And now I'm going to factor this further. We didn't factor this completely yet. This is a dot. It's a difference of two perfect squares. So that becomes x plus 1, x minus 1, x plus 1. And I'm going to rewrite that as x plus 1 squared, x minus 1. And I'm going to go back and call this y equals. We're going to graph this. Now the roots are at, let's see, actually let me go over here. Let me rewrite this. We got x plus 1 squared, x minus 1 equals 0. So at x equals negative 1 is a double root. X equals positive 1 is a single root. So single root at, call this one over here, double root at negative 1. Okay, so what's going to happen is we are going to get this curve is going to turn around at negative 1. That's the double root. And it's going to turn around again and go through positive 1. It has to touch negative 1 twice because it has a multiplicity of 2. So it has to turn around there. It has to go through positive 1, just straight through it. And this graph is going to look like this. Okay, so without even using my graphing calculator, just find the roots. Knowing that this was a double root, I could make a quick sketch of this graph. Okay, notice that the graph is tangent to the x-axis when x equals negative 1. This is called the double root. A double root will occur when two factors of the polynomial are equal. Okay? Okay, so more sketching a graph without the use of a calculator. So here we have the function. In fact, I'm going to do this on a separate sheet of paper just because it's going to take up more room than I have here. Here's what we got. We have the function, I'll write it larger, f of x equals x cubed minus 13x squared plus 44x minus 32. Now, I cannot do the factoring by grouping here because I'll show you why. If you try to group this, you're going to get x squared on the outside and then x minus 13 here. But when you factor this, you're not going to get an x minus 13 in parentheses. So you're not going to be able to get that common factor out. So instead what we're going to do, we're given the fact that one of the roots, or one of the factors, I should say, one factor is x minus 4. So if we divide this function by x minus 4, we'll get the rest of the function with the x minus 4 factored out. Let's see what that looks like. So we do our usual division. This is what we've been practicing last week. X goes into x cubed x squared times. Multiplying down, we get x cubed minus 4x squared. We subtract. This is going to become negative 9x squared. It's really change, so we're adding 4x squared here. Bring down that 44x. X goes into negative 9x squared, negative 9x times. Multiplying through, we get negative 9x squared. And that's going to be 30 plus 36x. We're going to subtract that. This is going to cancel, and that's going to become 8x. Bring down that negative 32. X goes into 8x 8 times. So you're going to get 8x and minus 32. And if we subtract that, we get nothing, no remainder. And what I want you to notice, I'm going to write it here. When we divide x minus 4 into this function, we get x squared minus 9x plus 8 as the other factor. And this is not factored yet, so we can factor this further. So let me show you what we've got so far. We got x minus 4 as one factor, x squared minus 9x plus 8 as the other factor, and this is not factored completely yet, so we can factor that more. finding two numbers that multiply to 8 and add up to -9, we're going to get a -8 and a -1. And this whole thing, well, we can make it equal to 0. So we can now find the x-intercepts of this graph. So if we make this chart, we get x equals 4 is one of the x-intercepts, x equal 8 is a second, and x equals 1 is a third. So we have all of these x-intercepts. At which x values can the function change from being positive to negative or negative to positive? These values. That's where it's going to be changing from going up to down or down to up, okay? To sketch the graph, we need to determine whether the function is positive or negative on the intervals between the x-intercepts and to the right and left. So I'm going to show you what this means. Here's the issue. If we start graphing like this, I'm going to put a line here for graphing. This is the y-axis and this is the x-axis. So this is 1, this is 4, and let's say this is 8 here. 1, 4, and 8. So we know that the function is going to go through here, but the function can go through here this way, or the function can go through here this way. So is it going this way, or is it going this way? I'm going to show you a little bit later on how you can definitely tell. But one thing you could do is you could just check values between -1 and 4, because it either has to be this possibility or this possibility. And we can check, let's say we check a value like 2 in the original function, and then we'll check a value like, let's say, actually, let's do this. Let's check 0 and 2. If we plug 0 into the regular function, into the original function, we're going to get -32. If we plug 2 into the original function, so 2 cubed is 8. 2 squared is 4, so that's -26. I'm sorry, let me just check that. 2 squared is 4, so no, it's not. It's going to be -52. 44 times 2 is 88, plus 88, -32. So that number is actually going to be bigger. Let me check that number. We get 8 minus 52 plus 88 minus 32, 12, positive 12. So that couldn't have happened this way. It must have happened this way, coming from low to high. So it's going to have to follow this path. So now we can make a sketch, okay? How can we tell? Okay, determine the intervals that need to, okay, so here's what we're going to do on our graph. This is 1, this is 4, and this is 8. We know it's going to go from here through 1, come down through 4, and back up through 8. So this is that function, an approximate sketch of that function f of x. Just so you know exactly where it turns around, we don't know. We just wanted to have a general idea of what the graph looked like. Instead of going this way, it's going this way. And again, there's going to be a quicker way for us to tell. You'll see later on. How do I know if it's going this way or if it's instead going to go this way? So we'll investigate that at another time. Okay, let's take a look at the last example here. All right, we have sketch a graph of the function. And this one's factored for us, so that's good. By finding the zeros and determining the sign of the values between the zeros. Okay, I'll actually go through this a little more quickly. So let me write this here. F of x equals x plus 5, x plus 1, x minus 2. If we set it equal to 0, then we get the following values. X equals -5, x equals -1, x equals +2. So on my graph, I'm going to set up an x and y axis here. We got -1 is going to be a turning point. -5, 2, 3, 4, 5. Not a turning point, an x-intercept. 1, 2, 3, 4, 5, and at +2. Okay, so we're going to have intercepts there. We just have to know if it's going to go down, down, or if it's going to go up, down, up. So I'm right over here, down here. Let's investigate. This was -5. this was -1, and this was +2. Let's try a value that's below, let's try easy values. Let's try a value that's down here, like -10, right? So -10 plus 5 is -5, okay? -5, that's gonna be negative. -5 plus 1 is -4, it's gonna be another negative. And -5 minus 2 is going to be another negative. So if we multiply all those, that's going to be, we don't know if it's -1, that's going to be a negative number. Negative times a negative times a negative, it's negative. So it should be starting down here and going up. Let's just check. Let's try a number in this interval here. Let's say -3. So that's going to give us a positive. That's going to give us a negative and a negative. That's going to be positive. So essentially, the next in here, it's going to be positive. So we're going from negative to positive. And then we know that it's going to have to follow this format here. Up, and then down, and then up. And this function is going to have that form, okay? We'll talk more about how you graph these functions in the future, but I hope this makes sense, and now you can do your homework.